On July 21st, 2023, at NASA's Jet Propulsion Laboratory in California, something happened that had never happened before in the 46-year history of one of humanity's greatest missions. A routine batch of commands was transmitted across more than 12 billion miles of space to a spacecraft called Voyager 2. The commands were supposed to be harmless. Standard housekeeping. The kind of instructions the team had sent thousands of times before. But hidden inside that transmission was a mistake. And when it reached the spacecraft, nearly 19 hours later, Voyager 2 did exactly what it was told to do. It turned its antenna, not dramatically, not a full spin, just 2 degrees, 2 degrees. To put that in perspective, hold your arm out in front of you and look at the width of your thumb. That is about 2 degrees of sky. It is nothing. It is a rounding error. But across 12 billion miles of empty space, 2 degrees is a catastrophe. Because Voyager 2's antenna was no longer pointing at Earth. And a spacecraft that cannot point at Earth cannot hear us. And we cannot hear it. Just like that, in a single moment, one of only 2 machines humanity has ever placed in interstellar space went silent. No data, no signal, no way to send a correction, because the spacecraft's receiver was now aimed at empty space, listening to nothing. The mission that had survived 46 years, 4 planets, and the crossing into the space between the stars had been silenced by a single line of code. But here is what the headlines never told you. The silence is only the beginning of this story. What NASA did next to get Voyager 2 back is one of the most audacious rescue operations in the history of space exploration. And what the spacecraft was carrying when it came back, the data it had been collecting out there in the dark, is quietly rewriting what we thought we knew about the bubble that protects every living thing on Earth. Stay with me, because by the end of this video, you will understand why scientists consider this half-blind, half-frozen 48-year-old machine one of the most important scientific instruments that has ever existed. I am your name, and this is your channel. Subscribe now if you want more stories like this, because we are just getting started. To understand what was lost in that moment of silence, you have to understand what Voyager 2 actually is. And that story begins with a piece of luck so absurd that it almost sounds invented. In the 1960s, a graduate student running calculations at JPL noticed something remarkable. In the late 1970s, the 4 giant planets of our solar system, Jupiter, Saturn, Uranus, and Neptune, would drift into a rare alignment. An arrangement that would allow a single spacecraft to visit all 4 of them, using the gravity of each planet as a slingshot to throw it onward to the next. This alignment happens roughly once every 176 years. The last time the planets had lined up this way, Napoleon was alive. Miss the window, and no one alive on Earth would see the next one. NASA did not miss the window. On August 20th, 1977, Voyager 2 lifted off from Cape Canaveral. And here's a detail most people get wrong. Voyager 2 launched first, 16 days before Voyager 1. Its twin would take a faster route and overtake it, but Voyager 2 was given the harder, longer, more ambitious assignment. The Grand Tour. All 4 giants. No spacecraft had ever attempted it. No spacecraft has ever done it since. What followed was 12 years of discovery that rewrote the textbooks. At Jupiter, Voyager 2 watched volcanoes erupting on the moon Io, the first active volcanoes ever seen beyond Earth. At Saturn, it sliced through the plane of the rings and revealed them to be not a few broad bands, but thousands of intricate ringlets, a structure of impossible delicacy. Then, in 1986, it did something no machine had ever done and none has done since. It reached Uranus. It discovered 10 new moons in a matter of days. It found a magnetic field tilted at a bizarre angle, unlike anything scientists had predicted. And decades later, researchers re-examining that data realized something almost comical. Voyager 2 happened to fly past Uranus during a rare solar wind event that had squashed the planet's entire magnetic bubble, meaning our only close-up visit caught the planet on one of its weirdest days. For nearly 40 years, our textbook picture of Uranus was based on a fluke. In 1989, Voyager 2 arrived at Neptune, the last stop, and found a world of supersonic winds, the fastest in the solar system, and a giant dark storm the size of Earth. On Neptune's moon, Triton, it photographed geysers erupting from a surface so cold that nitrogen itself had frozen solid. 12 years, 4 planets, dozens of moons, thousands of discoveries, and it did all of it with technology that should humble every one of us. Voyager 2's onboard computers hold a tiny fraction of the memory of the phone you might be watching this on. Its data recorder works on the same basic principle as an old 8-track tape. The engineers who built it were working with slide rules and punch cards, designing a machine that had to survive radiation, cold, and half a century of wear with no possibility of a repair visit, ever. And their creation has now outlived many of them. There are people working on the Voyager team today who were not born when the spacecraft launched, decoding transmissions from hardware their grandparents' generations soldered together by hand. When the tour was over, when the cameras had taken their last pictures, the mission did not end. Voyager 2 simply kept going, falling outward, away from the sun, into territory no map had ever covered. And that is when the real mission began. Because our solar system does not just end, it is wrapped inside a bubble. The sun constantly breathes out a stream of charged particles called the solar wind, and that wind inflates a vast protective cocoon around all the planets called the heliosphere. It shields us from the harshest cosmic radiation pouring in from exploded stars across the galaxy. Every living thing that has ever existed has lived. Its entire life inside that bubble. The edge of it, the boundary where the sun's wind finally dies against the pressure of interstellar space, is called the heliopause. And on November 5th, 2018, Voyager 2 crossed it. It became only the second object in human history to leave the heliosphere and enter true interstellar space. But here's the part that makes Voyager 2's crossing more scientifically precious than its more famous twins. When Voyager 1 crossed the boundary in 2012, one of its most important instruments, the plasma science experiment, had been broken for decades. It crossed the most important boundary in our cosmic neighborhood, partially blind. Voyager 2's plasma instrument still worked, which means that when Voyager 2 punched through the heliopause, humanity got its first direct working measurement of what that crossing actually feels like. And what it measured stunned the scientists waiting back on Earth. The boundary was not the gradual fuzzy transition many models expected. Voyager 2 slammed through it in less than a day. The wall between our solar system and interstellar space was sharper and thinner than anyone had predicted. On the far side, the temperature of the plasma was tens of thousands of degrees hotter than expected. A seething environment where the matter between the stars presses against our bubble. And then came the strangest discovery of all, the boundary leaks. Voyager 2's instruments detected material from inside our heliosphere trickling out into interstellar space like a slow leak from a balloon. The magnetic fields on either side of the boundary, which were supposed to be separate, lined up in ways the textbooks said they should not. Both Voyagers found this, and it remains one of the deepest unsolved puzzles in space physics. The bubble that protects all life on Earth is not a solid wall. It is porous, dynamic, and connected to the galaxy outside in ways we are only beginning to understand. Now stop and sit with what that actually means for you, personally. That bubble is the reason complex life can exist here. It deflects a huge portion of the galactic cosmic rays, the ultra-high-energy particles fired out by dying and exploded stars that would otherwise pour down through our atmosphere. Scientists believe that when our solar system passes through denser regions of the galaxy, or when the sun's output weakens, that shield can shrink and let more radiation through. And some researchers have even proposed links between those episodes and changes in Earth's climate and biology across deep time. We are not separate from the galaxy. We are floating in it, protected by a bubble of solar breath, and Voyager 2 is the only working set of eyes we have ever had on the outside of that bubble, measuring exactly how strong, how leaky, and how strange our protection really is. This is what Voyager 2 is doing out there. This was the data streaming back, hour after hour, year after year. The only working plasma measurements from interstellar space our species had ever obtained. And in July of 2023, because of 2 degrees, all of it went silent. Now, this was not the first time the team had faced a crisis. In 2010, Voyager 2 suddenly began transmitting gibberish, unreadable nonsense, and engineers traced the problem to a single bit of computer. Memory that had flipped from a 0 to a 1. 1 bit, out in the void, knocked sideways, most likely by a strike of cosmic radiation. They fixed it by radio. And in 2020, Voyager 2 endured almost a year of enforced loneliness for a completely different reason. Here is something almost nobody knows. Because of the direction Voyager 2 travels, dipping below the plane of the planets on a southern trajectory, there is exactly one antenna on the entire planet Earth capable of sending it commands. One, a giant 70-meter dish in Canberra, Australia, called Deep Space Station 43. No other transmitter on Earth can reach it. Let that sink in for a moment. Humanity's entire ability to speak to one of its 2 interstellar ambassadors depends on a single structure, on a single patch of ground, on one continent. If that dish is down, our species is mute. A storm, a mechanical failure, a power outage in one facility in Australia, and there is no backup, no plan B, no other voice loud enough and aimed at the right piece of southern sky. We have built a civilization that can whisper across 12 billion miles, but only through one open window. And in March 2020, that window had to close for critical upgrades. For the better part of a year, Voyager 2 could still talk to us, but we could not answer. If anything had gone wrong during those months, the team could only have watched, helpless. The spacecraft flew alone through interstellar space, faithfully transmitting to a planet that could not reply. But the 2023 silence was different. This time, the antenna itself had turned away. The spacecraft was not transmitting to Earth at all, and it could not hear any command we sent, because its receiver was pointed at nothing. Inside JPL, the team confronted a nightmare scenario with only one thin thread of hope. Buried in Voyager 2's ancient programming was a safety routine written decades earlier. Several times a year, the spacecraft automatically uses the sun and the star canopus to reorient itself and repoint its antenna at Earth. The next scheduled reset was October 15th, 2023, months away. In theory, the spacecraft would fix itself. In theory. But this was a 46-year-old machine running on 1970s hardware in the most hostile environment imaginable. Waiting meant months of lost data and months of trusting that nothing else would go wrong on a spacecraft nobody could talk to. The team wanted Voyager 2 back now, and what they tried next sounds like something out of a movie. First, they listened. NASA's Deep Space Network, the global web of giant antennas that communicates with missions across the solar system, strained to detect anything at all coming from Voyager 2's position. And they found something. A whisper. The spacecraft's carrier signal, the faint underlying tone of its transmitter, was still barely detectable, smeared across the sky by the misaligned antenna. It was far too weak to carry any data. But it meant one thing, and the team gave it a name that stuck, a heartbeat. Voyager 2 was alive, broadcasting into the dark, unaware that no one could hear its voice, but alive, and if it was alive, there was a chance. The plan they settled on was desperate, simple, and beautiful. If the spacecraft's receiver was pointed slightly away from Earth, then maybe, just maybe, the edge of that misaligned antenna could still catch a command if the command was loud enough. So, on August 2nd, 2023, the giant dish in Canberra turned to face Voyager 2's position in the sky and did something engineers described as an interstellar shout. It blasted the correction command at the spacecraft at the highest power available, aiming not for a clean connection, but for the faint hope that the fringe of the antenna's hearing would pick up the scream. Then came the wait. The signal, traveling at the speed of light, the fastest speed the universe allows, needed 18.5 hours just to reach the spacecraft. If the command landed, if the spacecraft heard it and obeyed, its response would take another 18.5 hours to crawl back. 37 hours. A day and a half of absolute silence, with nothing to do but watch the clock and hope that a machine older than most of the people in the control room would hear a whisper on the edge of its deafness and turn its head. Think about what that wait actually felt like from inside that room. There is no progress bar. There is no status update. The command left Earth and simply ceased to exist as far as anyone could tell, swallowed by the void. You cannot check on it. You cannot resend it faster. The laws of physics themselves are your bottleneck, because nothing in this universe, no technology we will ever invent, can carry a message faster than light. So you go home, you try to sleep. You come back, you drink coffee you do not taste, and you stare at a screen waiting to see whether a shout thrown across 12 billion miles of darkness landed on the trembling edge of an antenna the size of a satellite dish, on a spacecraft, moving away from you at 10 miles every second. 37 hours later, the screens at JPL lit up. Data. Clean, structured, healthy data. Voyager 2 had heard the shout. It had swung its antenna back toward a pale blue dot it has not seen up close since 1977, and it had resumed its report as if nothing had happened. The spacecraft was back on its trajectory. Its instruments were healthy, and the stream of interstellar measurements, the only ones of their kind in human history, began flowing again. The team had reached across 12 billion miles and fixed a 2-degree mistake with a radio wave and shear nerve. And this is where the story stops being about a rescue and becomes about what the rescue was for. Because when Voyager 2 came back online, it did not come back to retirement. It came back to a mission that is more scientifically important now than it has ever been. Every measurement it takes out, there is a measurement no other machine can take. Its twin, Voyager 1, is farther away, but crossed the boundary with broken plasma instruments. Every future interstellar probe exists only on paper. Even if one were approved and launched today, it would take decades to reach the boundary. Voyager 2's readings of the leaking, turbulent, magnetically tangled edge of our solar system are not just the best data we have. For this generation, and probably the next, they are the only data we will ever get. And the clock is running out. Both Voyagers are powered by radioisotope generators, blocks of slowly decaying plutonium that convert heat into electricity. Every year, that power drops by about 4 watts. There's no recharging, no solar panels that would work in the darkness out there, no reprieve. Just a slow, predictable fade. The team has been fighting that fade with everything they have. They have switched off heaters. They have shut down systems one by one. In 2023, engineers found a way to tap a small reservoir of backup power hidden inside a voltage safety mechanism, squeezing extra years of science out of hardware that was designed for a 5-year mission. But the arithmetic is merciless. In late 2024, Voyager 2's plasma science instrument, the very instrument that gave humanity its only direct measurements of the interstellar boundary crossing, was switched off to save power. In March 2025, its low-energy charged particle instrument followed. Its cosmic ray subsystem was next on the list. One by one, the spacecraft's senses are being turned off so that its heart can keep beating. Engineers now believe that with careful management, including an audacious power juggling procedure they have reportedly nicknamed the Big Bang, at least one instrument could keep operating into the 2030s. After that, Voyager 2 will fall silent for the final time. And unlike July 2023, there will be no heartbeat to find, no shout that can bring it back. But even then, the mission will not truly be over. Because bolted to the side of Voyager 2 is a golden phonograph record, identical to the one on its twin. It carries greetings in dozens of human languages, the sounds of wind and rain and a beating human heart, 90 minutes of music from across our civilization, and a map showing exactly where, in all the galaxy, the hands that built it lived. Long after the last watt of power is gone, Voyager 2 will keep moving at more than 34,000 miles per hour, carrying that record through the space between the stars. It will outlast the mission. It will outlast NASA. It will, in all likelihood, outlast every structure humanity has ever built. A message in a bottle thrown into an ocean with no far shore, from a species that decided the throw itself was worth it. Here's what I want you to take away from all of this. In the summer of 2023, we came within 2 degrees of losing one of the most valuable scientific instruments our species has ever created. 2 degrees, and the only working window into the space between the stars nearly closed forever. It was saved by a piece of 1970s engineering humble enough to include a self-rescue routine, and by a team of human beings stubborn enough not to wait for it. Right now, as you watch this, Voyager 2 is more than 13 billion miles away, farther from home than when it went silent and still going. Its signal takes nearly 20 hours to reach us, stretched so thin that by the time it arrives, it carries less power than a falling snowflake. And inside that impossibly faint whisper is information about the shield that protects every living thing you have ever known, information we cannot get from anywhere else, from any other machine, at any price. The spacecraft is dying, slowly, gracefully, 4 watts at a time. But it is not dead. And every single day it survives. It tells us something about the universe that we did not know the day before. The silence is coming. But it is not here yet. And as long as that heartbeat keeps crossing the void, we owe it to the people who launched it, and to ourselves, to keep listening. If this story gave you chills, subscribe right now and turn on notifications. Because the edges of what science knows are exactly where this channel lives. Drop a comment and tell me which moment hit you hardest, the 2 degrees, the heartbeat, or the shout. And share this video with someone who thinks the space program's greatest days are behind it. Because 13 billion miles from here, a machine from 1977 is still proving them wrong.